Before human-made climate change, was Earth actually in a cooling phase? And this is by the scientists Ellie Broadman and Darrell Kaufman on The Conversation on Science Alert. Over the past century, the Earth's average temperature has swiftly increased by about 1 degree Celsius, thus 1.8 degrees Fahrenheit. The evidence is hard to dispute, and it comes from thermometers and other sensors around the world. But what about the thousands of years before the Industrial Revolution, before thermometers and before humans warmed the climate by releasing heat-trapped carbon dioxide from fossil fuels? Back then, was Earth's temperature warming or cooling? Even though scientists know more about the most recent 6,000 years than any other multi-millennial interval, studies on this long-term global temperature trend have come to contrasting conclusions. To try to resolve the difference, they concluded and conducted a comprehensive global scale assessment of the existing evidence, including both natural archives like trees, tree rings, and seafloor sediments, and climate models. Our results, published in February 2023, suggest ways to improve climate forecasting to avoid missing some important slow-moving, naturally occurring climate feedbacks. Global warming in context. Scientists like us who study past climate or paleoclimate look for temperature data from far back in time, long before thermometers and satellites. We have two options. We can find information about past climate stored in natural archives, or we can simulate the past using climate models. There are several natural archives that record changes in the climate over time, the growth rings that form each year in trees, stalagmites, and corals can be used to reconstruct past temperatures. Similar data can be found in glacier ice and in tiny shells found in the sediment that builds up over time at the bottom of the ocean or lakes. These serve as substitutes or proxies for thermometer-based measurements. For example, changes in the width of the tree rings can record temperature fluctuations. If the temperature during the growth season is too cold, the tree ring formation that year is thinner than one formed from a year with warmer temperatures. Another temperature proxy is found in seafloor sediment, in the remains of tiny ocean-dwelling creatures called foraminifera. And when the foraminifera is alive, the chemical composition of its shell changes depending on the temperature of the ocean. When it dies, the shell sinks and gets buried by other debris over time, forming layers of sediment on the ocean floor. Paleoclimatologists can then extract sediment cores and chemically analyze the shells in those layers to determine their composition and age, sometimes going back to millennia. Climate models, or other tools for exploring past environments, are mathematical representations of Earth's climate system. They model relationships among the atmosphere, biosphere, and hydrosphere to create our best replica of reality. Climate models are used to study current conditions, forecast changes in the future, and reconstruct the past. For example, scientists can input the past concentrations of greenhouse gases, which we know from information stored in tiny bubbles in ancient ice, and the model can use that information to simulate past temperature. Modern climate data and details from natural archives are used to test their accuracy. Proxy data and climate models have different strengths. Proxies are tangible and measurable, and they often have a well-understood response to temperature. However, they are not evenly distributed around the world or through time, and this makes it difficult to reconstruct global continuous temperatures. In contrast, climate models are continuous in space and time, but while they are often very skillful, they will never capture every detail of the climate system. A paleotemperature conundrum. In our new review paper, we assess climate theory, proxy data, and model simulations focusing on indicators of global temperature, and we carefully considered naturally occurring processes that affect the climate, including long-term variations in Earth's orbit around the Sun, greenhouse gas concentrations, volcanic eruptions, and the strength of the sun's heat energy. We also examined important climate feedback such as vegetation and sea ice changes that can influence global temperatures. For example, there's a strong evidence that less Arctic ice, sea ice, and more vegetation cover existed during a period around 6,000 years ago than in the 19th century. That would have darkened the Earth's surface, causing it to absorb more heat. Our two types of evidence offer different answers regarding the Earth's temperature around 6,000 years ago, before modern global warming. Natural archives generally show the Earth's average temperature roughly 6,000 years ago was warmer by about 1.3 degrees Fahrenheit compared to the 19th century median, and then cooled gradually until the Industrial Revolution, and we found that most evidence points to this result. Meanwhile, climate models generally show a slight warming trend, corresponding to a gradual increase in carbon dioxide as agricultural-based societies developed during the millennia after ice sheets retreated in the northern hemisphere. How to improve climate forecasts. Our assessment highlights some ways to improve climate forecasts. For example, we found that models would be more powerful if they were more fully represented certain climate feedbacks. One climate model experiment that included increased vegetation cover in some regions 6,000 years ago was able to simulate the global temperature peak we see in proxy records, unlike most other model situations which don't include this expanding vegetation. Understanding and better incorporating these and other feedbacks will be important as scientists continue to improve our ability to predict future changes. This is by Ellie Broadman, postdoctoral research associate in climate science, University of Arizona, and Darrell Kaufman, professor of earth and environmental sciences, North Arizona University. From the conversation, Creative Commons on Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box